Thank you very much. It's lovely to be here. My talk is called The Quest for the Pocket-Sized Python. It is fantastic to be here for the first time at PyCon Australia as a speaker. I've been told that I'm an organizer this year. I'm not an organizer. Do not believe anybody who tells you this. But that is pretty much the extent of the Python stuff that I've been doing for a few years now, because my professional career is as an Android developer, and this is kind of sad because I work mostly in Java as my programming language at work, which is terrible. But my job is basically, I work on a large-scale multi-platform app, and this means that I touch code on Android, iOS, Mac OS X, Windows, and if I get told to, I write a bit of Java services code as well, which is kind of sad. I cry myself to sleep quite frequently. So last year at PyCon Canada, I gave a talk on the state of Python on Android. And a couple of months later, various online fora picked it up. Here's Reddit's Android section. This comment here summarizes the state of that, or the results of that talk in a bit of a nutshell. My talk was upsetting. I concluded that there isn't really a good solution for making native Android apps on Android or iOS. Games, apps with custom user interfaces are a bit of an exception. So you might be wondering, what has changed in 1 year? Has anything changed? No. Sorry. So today's talk, hopefully things that are a bit less upsetting than the talk I gave last year, which I do strongly recommend you go and watch or read the slides for. I'm going to focus mostly on people who develop real Python stuff, web developers, other Python enthusiasts. I'm not going to cover too much about making real native apps, stuff like that. I don't think the support is there. If you want to go and develop native, apps that run on Android, run on iOS, go check out Kivy, go look at Brendan's talk, use your time machine. So I'm going to talk about a couple of things, mostly developing web applications and what we can do about making pure Python apps that run on your choice of mobile platform. And something that I was going to talk about but don't have the time for is this thing that I call hybrid approaches. But to start things off, we'll recap a bit about what we're talking about today. So mobile devices, they're a thing. So I had one of these for a while. This is a pretty representative mobile device. Basically, it was a device that would make phone calls, it would send some texts. It, in fact, had an app as well. Snake was fantastic. But that was really the extent of what phones and these sorts of things were. In the early 2000s, we had this thing called the Pocket PC. It was like a PC, but scaled down so it would fit in your pocket. And, well, this was a bad idea as well, because the sorts of apps that we made for these things, well, that's like a spreadsheets graphing chart thingy program. But scaled down, to actually operate those buttons down the bottom, you'd need a stylus to operate it. And these aren't really devices that we care about anymore because they're awful to use. So mobile programming as we know it basically came around in 2008. And there's three aspects of them that we really care about. The first one is capacitive touchscreens, so you can actually use your thumb to operate it. Devices you can use with your hands. Now these required new user interface frameworks beyond what we had previously, because design approaches to that older UI toolkits took up didn't really cater for mobile. Software-based keyboards means that we have to deal with the available amount of content on our screen, changing very frequently, and it also makes for users that really hate typing because software keyboards are generally awful. We also lose precision from mouse pointers because we have to use our thumbs instead of cursors, so we have to make our designs less dense and make points of interaction really clear. And from a Python developer's point of view, we have this problem of app stores, which basically create rules for what things can be installed on a given class of device. Now, on both Android and iOS, app stores act as the only way of discovering which apps are available for a platform. So you might be wondering where Python fits into this whole situation. So as with my talk last year, everything is still pretty bleak. So iOS, lots of people use iPhones, use iPads. For a very long time, any language that was not anointed by Apple was banned from the App Store. This was sort of as a way of getting rid of Flash on iOS, but languages like Python, like Ruby, all these other languages that aren't Objective-C or C or whatever, were basically banned from iOS as collateral. So Python was collateral. And these days, who saw the WWDC keynote back in June? So these days, Apple are kind of hostile towards Python. Basically, they developed a new language called Swift, and then they created some bogus benchmarks that basically made Python look as absolutely dreadful as they possibly could make it, like doing complex object sorts, whatever that means, or doing CPU-bound encryption, which also is not particularly good in CPython. So iOS is kind of sort of hostile towards Python as it is. And the other platform that we have, well, we have Android, and that's a bit weird. We know a lot about Java. The Python community knows a lot about Java. Jython is a thing. It works really well. But Android doesn't actually use the JVM. It uses this weird thing that's kind of sort of like the JVM, but not quite, called Dalvik, which basically means that Jython doesn't work on Android, and you can't access Java APIs on Android. It's taken people who aren't from Google, because Google didn't care about putting Python onto Android. It's taken them quite some time to figure out how to make things work. And since people have figured out how to make things work, well, Google have gone and changed things again, which is very kind of them, making it really difficult for us Python developers to actually get stuff onto our phones. Now, for people who come from the web, the systems world, we have the privilege of being able to choose what language we use to develop. Now, we're all sensible people. We like Python. But in the mobile world, things are odd. Languages are anointed as official. APIs tend to be written in really specialized calling formats that require the specific language you have, and re-implementing the APIs in some other language would be time-consuming, difficult, and something you would not want to do unless you were paying someone quite a bit of money. Mobile is also interesting in that the platforms have consistent design standards. So official APIs, which require official languages, make it easy for you to get at the design standards that each platform uses. And people who are implementing alternative toolkits have to play catch-up, which is kind of dreadful as well. And finally, there doesn't appear to be any real work in making Python happen on iOS or Android coming from any commercial entities. It's all happening on people's spare time in the community. This means people have specific needs that are filled rather than trying to solve a general problem that will solve a problem as a whole. It's not necessarily a bad thing, but it's at odds with the mobile industry. People are basically using toolkits that are out there. People aren't interested in making toolkits by and large. So in summary, mobile is not a thing that resembles any other thing that people have been developing for, and Python has been artificially disadvantaged. So I hope you're all happy with the state of things. The world is a wonderful place. So the rest of this talk is basically a grab bag of things you can do without actually coding Python or making native mobile apps in Python. And I'm going to take a guess. Most people here are generally interested in the web because they're the people making consumer-facing stuff. Am I right in that assumption? Web developers here? Cool. A reasonable number of you. So this is a quick overview and some pointers as to how web developers should approach mobile development. Now, if you're an astute observer, you'll note that I'm not actually talking about Python on mobile, because if you think you're a Python developer doing web front-end things, you're also delusional because you're actually writing JavaScript. So what I'm talking about is basically what you're doing with desktop web. You're writing your services code in Python, and you're doing HTML and JS for the user interface. So the key difference between designing for full-size computers and versus mobile devices is to actually consider how your design will work in a touch context. Now, touch is interesting because you have basically meat pointers as opposed to a mouse. So this is a picture out of Google's design guidelines for Android. Basically, touchscreens, they don't have a whole bunch of precision for touching things, and it's difficult to tap things precisely. So designs that pack a whole bunch of things into the same place are really difficult to use. So this is a thing that Google call the 48-pixel grid. They don't actually call it that. I call it that, but their name is a bit weird. In this design, basically, having touch targets that divide your grid up by 48 pixel blocks actually gives you a clear amount of spacing for your widgets and stuff like that. So you can see that button there is about 40 pixels high. It has some spacing to make sure that you don't miss it. This is the thing you should do on your mobile websites. It means that you don't create things, like if you're densely packing your hyperlinks on a web page, for example, it's very easy to accidentally touch the wrong thing. So as a rule of thumb, keeping your tap targets 40 pixels wide, 40 pixels high, makes things easier to tap. Now, cell phones are operated with hands. I don't know about you. I can't see through my hand. It's a device I can't see through. Basically, if you operate a thing with your hands, you generally can't see the things that are under your hands while you're using your phone. So designing navigation structures so that things that you don't need to see the content for goes up the top means that it's easier to, or it makes more sense to put those things there and things that you do need to see the content for down the bottom. The final thing that I want to talk about in design, who here has heard of responsive design? Who here thinks that's a good name for it? Yeah, okay, good. So I call this what I think it actually is, which is constraint responsive design, which is basically dealing with the available width and height of a device and changing whenever the available constraints change. This is kind of important for mobile because keyboards appear and disappear quite frequently because people change their phone from portrait to landscape quite frequently, and this drastically limits the space you have to display things. So here's an example. I have an Android phone. This is in portrait mode. It's great for showing long pages with lots of height, but not wide images. You can see a whole bunch of stuff is cut off. And if I put my keyboard up, well, I lose about a third of my height. And if I swap over to landscape, well, I can see more of that picture, but then if the keyboard pops up, I lose sort of half of it. So if you're doing design stuff, you should make sure that your design works in basically every orientation you have it, with the keyboard up, with the keyboard down. Responsive design is kind of important for that. And the final thing I want to touch on is discoverability of web apps. Web apps have a kind of a big disadvantage compared with apps that are packaged for a mobile platform. The web is hugely inaccessible on mobile devices because software keyboards are difficult to type on. Coming back to pages is difficult because it's difficult to bookmark things and navigate bookmarks on mobile devices. So you kind of want to be accessible on app stores. To make a point here, I'm going to make an app shortcut from Chrome for a conference that I was at last week. So to do that, I have to open my browser, I have to type a URI. When the page loads, and then I have to press a bunch of link targets to find a schedule, and then I have to press a button here, and then this really obvious button that says add to home screen is the one that I need to press. And then if I forgot to add a favorite icon, then the shortcut that I get on my home screen is this really obvious page with a world on it, as opposed to like a nice icon. This is kind of awful. The alternative is, of course, making yourself a nice app that goes in an app store where you search for the thing you want, you select the app you want, and there it is. So if you want to be found on mobile and you absolutely insist on using the web, you should make it easy to find your apps. It's not that hard, and it will get you more users. So you can create a simple wrapper that puts yourself in the Play Store or in the App Store on iOS. And that's sort of half the way there. For bonus points, you can make your web app behave a bit more like a mobile app. So the first thing you can do is to write a simple app that basically takes a web view and loads your page. But that's a bit lazy. People don't expect mobile apps to work like that. You need to meet users' expectations. Apps have a certain set of implied behavior that most web apps get wrong. This is things like resuming state when an app gets killed, being easy to navigate forward and backward, being able to remember where you are, and working offline. So basically, things that you need to do include remembering stuff across sessions, like remaining logged in even if an app gets killed. They should remember where they were, so they should launch again to the same page as they were in when an app gets killed, because if you change apps on a mobile platform, sometimes they get killed by the OS. This is a thing. And basically, you can do this by ensuring that every state of your web app has a unique URI. And for bonus points, they should function well offline using like HTML offline support. Toolkits like PhoneGap can be used to write full-featured wrapped HTML5 JavaScript apps, but they can also do basic web view wrapping like I've just described. It might possibly be a bit bloated here. So the message here to take home is that lots of people may say nasty things about web apps in mobile, but the truth is that if you play nicely, behave like a mobile app, then your users won't care that you're a web app. So go and do it. It makes your products easier to find. So the next thing I want to talk about is the pursuit of basically apps written in Python running on mobile devices. And when I did my survey of Python on mobile last year, I saw a bunch of contenders, including Pygame, including Qt, but there's really only one contender now, and that's Kivy. Kivy is the only thing that is making progress in terms of making Python run on Android, run on iOS. Now, Brendan Scott just gave a really extended talk on Kivy. Also, there's quite a few talks on that will cover Kivy better than I ever will. So if you want to do that, go look at those talks. So for those of you who want the quick overview of what Kivy is, it's really two things. There's firstly a UI toolkit with custom widgets that work across multiple platforms with a bit of a focus on touch applications. So people really think about this in terms of deploying Python, Kivy, using Kivy to deploy Python on iOS, to deploy it on Android. And then there's also a series of projects for embedding and deploying Python on mobile platforms. So Kivy is pretty fantastic. It's useful for doing a limited subset of mobile tasks. Kivy is really good at doing completely custom UIs. So if you don't care about making your app match the native look and feel of your system, then Kivy might be good. It will get you a cross-platform app quite quickly. This is a good thing if you're aiming to, so I need to read my notes better. So Kivy is not something for making native UIs on mobile platforms. It implements its own widget set, and it does not accurately replicate the feel of UI elements as they are on their own platform. So it doesn't implement the look and feel of iOS, it does not implement the look and feel of Android, and if they do, they're basically doing manual replication. They lag behind other platforms, and they won't feel quite as good as the official widgets. The exception here is where you're doing custom UIs. So if you do games, for example, where an Angry Bird does not need to look like a button. So Kivy is a perfectly good platform to do this sort of thing with, and you get to do things in Python, which is really nice. Kivy says it'll make the same app run on Android, iOS, Windows, Mac OS X, but you need to consider whether or not an app that works in a touch context will also work in a desktop keyboard mouse context at the same time. Just because something will run on multiple platforms, you should consider whether or not it should. One thing that has substantially improved over the last couple of years is access to hardware APIs on mobile platforms. People care about doing things like geolocation. You want to know where you are when you're mobile. Accelerometer access, things like that. These are things that make mobile devices more interesting than desktop devices. Now, the Kivy project has been the primary driver of this. They've produced a couple of projects, one called PyGenius and one called PyObjus. These are tools that wrap up complex interfaces on each platform's, they provide access to complex interfaces on each platform's preferred language. So PyGenius gives you access to the Java native interface on Android. It allows you to wrap Java classes in Python really quite quickly. And pyobjects does the same thing with Objective-C. So to give you sort of an idea of how this works, this is my first and probably one of two code slides in this talk. This is code to wrap an on-click listener in Android. So you basically say that this is a Python Java class, you say what Java interface it implements, and then you go and implement the JNI methods that you need to. The Objective-C version is also quite similar. This is pyobjects, wrapping NSString, which is the string class in Objective-C. It's quite easy to do, but you'll notice we have this funny trailing underscore thing. Objective-C has a really weird method calling syntax where you interleave parameters with parameter names. It doesn't quite translate well to Python. So there is a way to basically get to native Java and Objective-C classes within Python, but it requires a lot of boilerplate. Another Kivy project that's come around in just the last year is a thing called Plyer, which is basically a simple way for abstracting away various pieces of hardware. So they provide an accelerometer class in Python, which in turn calls the Android accelerometer class on Android using the JNI, and does the same thing on iOS using a consistent interface. So you can make cross-platform mobile apps that don't need to spend a lot of time implementing both the device APIs on each platform. The final frontier of mobile dev in Python, I think, is to access each platform's native UI libraries. It would be great because it means I wouldn't need to code Java in my day job. So the obvious candidates here are PyGenius and pyobjects again, but these are not quite there yet. They seem to be aimed mostly towards supporting Kivy apps. The bits of Android and iOS where GUIs come in are not terribly supported well by these projects yet. So for example, flaws on Android, if you want to access read-only classes, these are ones that you don't need to extend, you'll find there. That'll get you most of the device API access, but if you need to extend classes, you're out of luck. So Android uses managed classes that you need to extend in Java. You can't do that from Python just yet. And on iOS, the interface builder actions and outlets don't work in pyobjects, so you can't connect iOS native interface builder UIs. One interesting thing that I saw in the iOS 8 beta is that there's now actually a Python framework that you can deploy to iOS. So while they were slagging off on Python in the WWDC keynote, they actually released Python for iOS, which I thought was kind of curious. I have no idea what this means, but I think there's something to be read into that. I'm not quite sure what it is. We might know in a year or so. Yeah, I have no idea either, Richard. One thing that I touched on in a longer version of this talk is something called a hybrid approach, which is where you write a substantial part of your core logic in Python, but write your user interface code in your platform's preferred language. If you separate, or if you produce a really rich web API, for example, that's one way of doing it. So you make HTTP calls to a Python service. And it looks like, thanks to Kivy, it might be possible to embed an entirely Python services layer onto a native app and just write your UI code on your preferred platform. Have a chat to me later a bit more if you want to know a bit more about this. I do something similar in my day job, just not with Python. So this brings us to the end of the talk. There hasn't been much real progress in getting full apps that fit in with the rest of the system working on Python, and this is sad. But there's still a place for the Python coder in the mobile world. So firstly, we know that mobile sucks in general, and Python support on mobile also sucks, but it's still possible to write lots of Python on your back end and make your front end in other languages. That's the end of the talk. As far as schedule time is concerned, I have like 5 minutes for questions, I guess.
Yep. You have 5 minutes.
Fantastic.
Questions?
I'm entirely surprised by this first questioner.
Yes, I would never ask a question. You talked particularly about Android, but also on iOS, about whether the limitations here, are they technical impossibilities or just a matter of man hours or woman hours and resources being thrown at the problem?
Okay, so in the case of Android and the JNI, there is a fundamental technical limitation in terms of extending Java classes over the Java native interface. That's something that will not be solved without doing some level, I suspect, of code generation during a build phase. So producing something that will implement the subset of methods that you want to override on the Python side, but giving an interface so you can implement it on the Python side, which is basically how PyGenius works. In the case of iOS, I'm not sure whether or not that's a technical limitation. The PyObjective-C bridge on Mac OS X definitely supports the interface builder stuff. I'm not sure if there is actually a limit on iOS, though.
Okay, to that end, in about 20 minutes, half an hour's time, I'm giving a lightning talk, which may be relevant to your interests if on that particular topic. So
on the iOS side, or?
Well, maybe. I'll just leave it at that, shall I?
Okay, cool.
Alternatively, you can get someone working on Python that runs on Dalvik. Just saying.
Well, yes, Richard.
Yes, hello. I wonder if you could just touch a little bit more on this concept of having a native UI with a Python service.
Okay, so CPython will definitely run on Android. This is how Kivy works. It will run on iOS. Once again, that's how Kivy does its thing. I suspect it should be possible to call into Python from a Java activity, because once again, Kivy somehow needs to bootstrap an Android application. Kivy somehow needs to bootstrap an Objective-C application in order to launch the Python interpreter. There could be an avenue for extra work, for work here in actually making a wrapper that will allow you to call into Python from the preferred language of your platform. I haven't seen it done yet, but everything seems to be there. It just is something that hasn't been done. But it should be. Tennessee?
I'm going to ask a really ignorant question. I think on Android, the idea is that the applications, in theory, are supposed to be able to basically provide services to each other.
Right.
Couldn't you basically do a two-application process where one application's in Python providing services and another one's like a Java app that consumes services?
Yes, you could theoretically do that. The question is how you sort of provide the interface, and that's an unanswered question at the moment. Like HTTP might be a way to do it badly, but that could work as a way of doing interlanguage communication. Yeah.
So I've used Cordova or PhoneGap with web applications, and I'm just wondering, do you think given that there's work going on with transpiling Python across to JavaScript, that might be another way to develop cross-platform apps with Python?
Yeah, if you're happy to tolerate a web browser as your front end, then absolutely that would be a good way to do it. Go see Ryan Kelly's talk tomorrow on pypy.js for more on that. So if you're happy to tolerate the web as a front end, then that would be an interesting thing to do. It just depends on the power of your phone to interpret the massive block of JavaScript that is your Python interpreter. It should work right now. It's just whether you would want it to work or not is a different question. Any others?
Any other questions? All right. Well, you have 1 minute-ish.
Thank you.
Everyone, Chris.